Unit 5, quadratics in factored form, assignment 5.03, intercepts in factored form. So we are writing our quadratics, or we've been working on quadratics in factored form, which is this form right here. It is different than vertex form. Our vertex form looks something like this. Okay, and now vertex form, which is up here, is valuable because we can identify our vertex right away from the H and the K. Factored form allows us to find our intercepts, and specifically our x-intercepts, very quickly. It's a sloppy way of writing intercepts. So here's some notes. I recommend you copy this down on your worksheet. For all y-intercepts, you need to remember that our x value is equal to 0. And the exact opposite is true of x-intercepts. All x-intercepts have a y value that is 0. So what this means is that when we're trying to find an x-intercept, we want our y, which is this guy here, which is covered out, to equal 0. So we got to figure out what values go in for x to make our y 0. Well, if you remember, any number times 0 equals 0. So if I have one number here and another number here, if one of them is 0 and the other is any other number, it equals 0. So all we have to do is make one of these parentheses 0, then the entire thing turns 0, and we found an x-intercept. So looking at x minus 3. Well, how can we make this come out to be 0? What value goes in for x that comes out to be 0? Well, that would be positive 3. And if you can't see that, add 3 to both sides, and x would be 3. Same thing for the next one. We have x plus 4, set it to equal 0, and we're going to subtract 4 from both sides. So then x would equal negative 4. So at x equals 3 and negative 4, we have our y-intercepts. You're going to write that as 3, 0, and negative 4, 0. Once again, when we're looking at x-intercepts, our y value is 0. The exact opposite is true for our y-intercept. We're going to set our x to be 0. So I'll do this in red, erase all that. So for our y-intercept, x equals 0. So we substitute 0 in for both of our x's, and we do the math. 0 minus 3, 0 plus 4, minus 3 is, 0 minus 3 is negative 3, 0 plus 4 is 4, negative 3 times 4 equals negative 12. And remember, our x value is 0, so our coordinate would be 0, negative 12. I'm going to do the U try as well here. So we're going to set both these to equal 0. X minus 5 equals 0. Add 5 to both sides. We get 5, 0. And then we set the other one to equal 0. We add 7 to both sides. We get x equals 7. All right. And our y-intercepts, same thing. X is equal to 0. Plug that in for both of our x's. So 0 minus 5, that is negative 5. 0 minus 7 is negative 7. Don't forget this 2 out front. So I'm going to do the negatives first. Negative 5 times negative 7 is positive 35. Times 2. 2 times 35 is 70. So our y-intercept would be 0, 70. I want to make sure we talk about one thing real fast. Some of you might be recognizing that when we look at our x-intercepts, we're just taking the opposite number. So x minus 5 means that we get positive 5. X minus 7 means that we get positive 7. That's sort of true. Let's say I have an equation that looks like this. X minus 7 times 2x minus 3. Well, using that logic we just did, we can see this one. What is going to be the x-intercept here? Well, the additive inverse of negative 7 is positive 7. So you have 7, comma, 0. I want you to be careful on this one, though. This one in blue. It's not just positive 3. We need to set this whole thing to equal 0 and then solve it for x. First step we do is we add 3 to both sides. So we get 2x equals 3, and then we divide both sides by 2. So we get x equals 3 over 2, or 1.5. Like that. I want you to be careful so you don't look at this last number and just say, oh, it's positive 3. That's our x-intercept. That's not exactly true. We need to set this whole thing to equal 0 and then solve for it. When there's just a 1 in front of our x, there's no need to divide, like we did over here, at the very end. It's just simply you move the 7 over, and that's what the number equals, or the x equals. So it's not always just the second number's opposite number. Just want to let you guys know that, because we're going to do some problems like that later on in the unit.